ahead and start that recording now, and it is literally running already at this moment. And so this time close your laptops, please. Close your laptops and look at my big screen. This time they're asking for total resistance, and there's actually in number 2 there are 2 little circuits to do. One of them is the easy one, and the other one is the hard one. Which one would you like me to do for you right now? The hard one, of course. Just so you know, the easy one is so easy that whenever you have 3 resistors in series, in other words, it's just one path. Whenever you have 3 resistors in series, you just add them up. That's it. That's all you do is add them up. But when you have them in parallel, which is this one, which means there's multiple paths, that's where things get a little complicated. And so what I'm going to do is write number two, and nothing is there. All right, let's see if that's any better. I will zoom in just a moment after I get the circuit drawn. And so in this circuit, I have a straight horizontal line there, a vertical line with a squiggly resistor, and then another vertical line with a squiggly resistor, and then a third vertical line with a squiggly resistor, 3 resistors. And then they are all connected in parallel to a battery of an unknown voltage. Now, ordinarily, I would say you have to find out what that voltage is, but I think we're okay without. We'll worry about doing a complete circuit solution on number 3 and number 4 below. This first resistor is, I will zoom in a moment, I promise, 5.6 kilo ohms, and the next one is 680 ohms, and then the last one is 8.2, looks like kilo ohms again. And then we are trying to find the R sub T, which is the total resistance. So let me stop sharing my screen, and then we get that. That's better. That's pardon my penmanship. That's very embarrassing. But what's important here is we have to combine these 3 resistances, or we have to sum the total of these 3 resistances. This 5.6 kilo ohm and this 680 ohm, omega means ohm, and then 5.2 kilo ohm. And remember, we said that kilo is 1,000. So these numbers, this is actually 5,600, and that's actually 8,200. And when we don't notice that, of course, we make wrong answers. Now, in the series circuit, which I said was the easy one, in the series circuit, this is the equation. This is not the equation for the circuit that we're working on right now. But I hope you see that in the series circuit, you've just got 3 numbers, you need to add them together. But that is not the equation for this one. This is a parallel. So the parallel equation is going to look really strange. 1 over R sub T equals 1 over R plus 1 over R sub 2 plus 1 over R sub 3. And there would be more. This can continue forever depending on how many resistors you have. So this is what they call, or what I call, the sum of the inverse, or I'm sorry, I said it backwards. The inverse of the sum of the inverses. Every time you have something 1 over a quantity, you're looking for the inverse of that quantity. So in order to find this R sub T, this is our unknown. We have to know this one, and this one, which we do know. And so now it's substitution time. Let me see, maybe zoom out a little bit. Now it's substitution time. So it's going to be 1 over R sub T equals 1 over 5,600, because that's kilo, plus 1 over 680 plus 1 over 8,200, because that one is a kilo. So far, so good? Well, here's what you can do. You can just use a calculator and do 1 over 5,600 and then get a decimal. And you can use a calculator and get 1 over 680 and get a decimal. And then you can use a calculator and get 1 over 8,200 and get a decimal. You can do that. And then you can add up all those decimals. So let's do that now. What is the decimal you get for 1 over 5,600? I bet it starts with a 0.0, maybe even 0.00. What you got? 0.000178578. Okay, I'm just going to stop at there. 0.001798, you said was the 4th digit? Or 178? 1785. 1785, so I rounded it off to 179. Okay, then the next one, 1 divided by 680. What is 1 divided by 680? I bet it starts with a 0.0.
0.00147058.
Okay, I only took the 147 because I only care about the first 3 significant digits. However, Al, am I right that the digit after the 7 was less than 5?
Yeah.
Okay, so I rounded that one down, 0.00147. And then there's a third one, 1 divided by 8200. I bet it starts with a 0.00. I wonder if it has 0.000. 122. Can anyone confirm that? 122. There's a fourth digit that does not round us up to 3. Is that right?
Well, it was 121, but the fourth digit was 9.
Okay, so we rounded that to 0.000122. Now, these 3 numbers that you have now inverted, that's called the inverse. So we have now inverted those numbers. Now add them together for me. And what do we get with those 3 numbers added together? And again, I only need 3 significant digits. I bet it starts with 0.00. What you got?
177.
Can anyone confirm 177? Give me one more digit.
1.
What's the 5th digit after that one?
That's it.
That's 0.001771. Okay, now what we've done is we inverted each of those resistance values, and then we added that all together, and we got this sum of the inverse resistances. But we have to invert that value because 1 over R sub t is not R sub t. We need R sub t. So what you do in this case is the R sub t and the 0.001771, those, according to algebra, you can just switch what's on the bottom of one side with what's on the top of the other side. So if you did that, if you just switched them, then you would get 0.001771 in the denominator, and you would do 1 divided by that. So what is 1 divided by that? Anybody? 1 divided by 0.001771? 564. What's the next digit?
0.65.
Okay, so what I'm going to do is I'll include, usually I only like 4 digits or 3 digits, but I'll include 4 just because we're dealing with all these little numbers. Jess, is it 564.7 or is it 564.6? Okay, and then that is the total resistance, and the unit for resistance is an ohm, which is represented by an omega. And so that is the total resistance for the parallel circuit. And what I hope you notice, or that you just believe when I say that 5,600 plus 680 plus 8,200 does not add up to this. They would if you were doing a series circuit, but we're doing a parallel. That concludes this problem. Please open your laptops and continue working on these problems or whatever else you need to work on. 1, 2, 3 snap, 1, 2, 3 sim, 1, 2, 4 circuit calculations. Do all of those things.